بسم الله الرحمن الرحيم. We are still in this topic, which is the L'Hopital rule. In the first part, we discussed the first case of the indeterminate form. And we said that we have different type of indeterminate forms. We have 0 over 0. We have infinity over infinity. We have infinity minus infinity. We have infinity to power 0 or 0 to power infinity or 1 to power infinity or also 0 multiplied by infinity. And we said that the L'Hopital rule said that if we have 0 over 0 or infinity over infinity, say that the limit x goes to some real number a of a fractional function f of x divided by g of x is equal to the limit f prime x divided by g prime x as x goes to a, provided that f and g are differentiable at the given point or on an open interval containing x equal to a. In the last part, we gave different type of examples about the first form, 0 over 0. For today, we are going to speak about infinity over infinity and also infinity minus infinity, or also might be 0 multiplied by infinity. I want to say that use L'Hopital rule to find the limit. Number 1. Limit 5x squared minus 3x divided by, let's say, ln. Let's make it easy this time. 6x squared plus 4 as x goes to infinity. Before we said that if I have polynomial divided by another polynomial, we take the limit of the highest power for the numerator and the highest power for the denominator. And you can see that if we replace x by infinity, I will have infinity over infinity. This is infinity over infinity. It means that we can apply the L'Hopital rule. We said that if I have 0 over 0 or infinity over infinity, then we can apply the L'Hopital rule to find the limit. Now this is infinity over infinity. So if we want to use the L'Hopital rule, this will be limit of 10x minus 3 divided by 12x as x goes to infinity. Now again, if we replace x by infinity, we will see that x, or the numerator will go to infinity and the denominator also will go to the infinity. So again, this is infinity over infinity, which means that we can apply the L'Hopital rule for the second time. So this is equal to the limit 10 divided by 12 as it goes to infinity, which is equal to 10 over 12, or it is 5 over 6. So the limit for this function equal to 5 over 6. And if you remember that when we spoke about the limit at infinity, we said that we take the highest power in the numerator and the highest power in the denominator, and then we can see whether the limit exists or not. And since the power are equal, the limit equal to the coefficient, which is 5 over 6. And we got the same. It is 5 over 6. So the limit is equal to 5/6. Another example, number 2. Limit of ln x divided by x as x goes to infinity. You know, the graph of the logarithmic function is take this shape. This is ln. When x goes to infinity, the graph will go to infinity, or the function is moving to the infinity. So this one is infinity over infinity. So it is one of the indeterminate form. It means that we can apply the L'Hopital rule. By the L'Hopital rule, this is equal to limit ln x, we take the derivative, which is 1 over x, and derivative of x is equal to 1 as x goes to infinity. So it is 1 over x divided by 1, and this will give me 0 over 1, which is equal to 0. So the limit is equal to 0. Now for the next example, let's speak about something called the growth or decay of exponential function. But one thing here, the growth of functions. Using the L'Hopital rule. So that this is limit. If I have x to power n divided by some exponential function, let's say e to power x as x goes to infinity, is equal to 0. If the polynomial divided by exponential function, we say that the exponential function can grow or increases faster than a polynomial. So the limit of x to power n divided by e to power x equal to 0. The reverse, limit of e to power x divided by x to power n as x goes to infinity is equal to infinity. So what's positive and positive? So this is the growth of exponential function. It is faster than a polynomial. Using these basic rules for the exponential function, take the third example. Let's find the limit of x to power 100 x squared minus 1 divided by e to power x as x goes to infinity. If I want to apply the L'Hopital rule for this one and find the derivative for the numerator, I have to differentiate this one 100 times because I have x to power 100. For that, just notice that this is infinity over infinity. And we know that the limit of the polynomial is equal to the limit of the highest power. So we can write this as limit x to power 100 divided by e to power x. the limit of the polynomial is equal to the limit of the highest power. So this can be written as limit of x to the power 100 divided by e to the power x. Now if we go back to the first part in the growth expression, which is this one. Limit of x to the power n divided by e to the power x as x goes to infinity is equal to 0. So this is equal to 0. Because we can differentiate this 100 times, it will be 100 factorial. If we differentiate this 100 times, I will get in the numerator 100 factorial divided by e to the power x, which is finite over none or infinity. 100 factorial means 100 multiplied by 99 multiplied by 98, 97, 96 up to 1. Divided by infinity will give me 0. Because if we have finite number divided by infinity will give me 0. So the limit for this one is equal to infinity. Second more. Number 4. Find the limit to power x divided by x to power 5 minus 3x. X goes to plus infinity. This is the second part of that remark. If the exponential function is written in the numerator and the polynomial is in the denominator, so this can be written as just limit of 2 to power x divided by x to power 5. Take the highest power, and this will give me plus infinity. The limit is equal to plus infinity. What is infinity over infinity? So this will be equal to infinity. One more, number 5. Have that limit. Let me take this time. Okay. Tangent x divided by 1 over x minus y over 2, where x goes to y over 2. Yeah, what is the limit of this function? The tangent is taking the asymptote at minus y over 2 and y over 2. As we're reaching up y over 2, this will go for an infinity. And for the denominator, x minus y over 2, let's say, let's take it from the positive, so that it will be sure that this will go for the infinity. 1 minus, or x minus y over 2, this should be go for the negative, I'm sorry, this should be negative sign. This will be infinity over infinity, or infinity over minus infinity. Which is indeterminate form. So we can apply the L'Hopital rule. Is equal to the limit. Derivative of the tangent x, the derivative of tangent is secant square. Divided by derivative of 1 over x minus y over 1. We can apply the quotient rule. It will be minus 1 divided by x minus y over 2 square. as x goes to pi over 2, negative pi over 2. Now this one, if we replace x by pi over 2, I will have 0 over infinity. Because second of, I'm sorry, it is infinity over infinity again. This is infinity over infinity. Because second is 1 over cosine. 1 over cosine pi over 2 equal to 0. So it is 1 over 0 equal to infinity. And downwards will be minus infinity. So it's again infinity over minus infinity, which is indeterminate form. If we differentiate again, we will have something more complicated. So before doing that, let's simplify the function. Let's try to simplify it. We simplify this one. In some cases, we need to simplify the function before doing anything. This is limit of secant square is 1 over cosine. So I will have, write it down, space. One over cosine x over minus 1 over x minus pi over 2 square. This goes to pi over 2 minus, or from the left. We simplify it. This will come down and this will go up. This is equal to limit of minus x minus pi over 2 square divided by cosine square x as x goes to over 2 minus. Now it is of the form 0 over 0. Which means I need to apply the L'Hopital rule. So this is equal to the limit minus 2 x minus pi over 2 divided by the derivative of cosine square is equal to 2 cosine x multiplied by minus sine. So this will be minus sine. X goes to pi over 2. Again, this is 0 over 0. So let's apply the L'Hopital rule for the second time. I can take this negative from this one, up and down. So I will have limit x goes to pi over 2. For the numerator, I will have 1. For the denominator, it is a product of cosine and sine. It will be the derivative of cosine will be sine, which is sine x multiplied by sine x plus sine x times cosine x as x goes to pi over 2 negative. But we know this is equal to 0 when x equal to pi over 2. So this will be limit x goes to pi over 2 minus 1 divided by sine square. And sine square at pi over 2 equal to 1, so this is minus 1 over 1, which is equal to 1, or minus 1. So the limit for this function equal to minus 1, and you can see, we applied the L'Hopital rule many times. We need to simplify the function. In some cases, we need to simplify the function and apply the L'Hopital rule to see what is the limit of the given function. Just repeat the L'Hopital rule many times, or simplify the problem, make it easier to differentiate or to find the limit. And as you can see in this example, we got minus 1.